make it work, it works.
So what I'm saying is that this follows that pattern, or this follows this pattern.
Yeah.
This pattern, right?
Okay.
It does follow that pattern, because if you keep writing this, like make it this smaller, this smaller, right? You're gonna write another one. I can write another one to match the other one.
Okay.
Right. So let's say, well, if I try one more here, n minus 1, n minus 2 plus a like n minus 3, right?
Yeah.
So what follows here is r to the power of n minus 1, r to the power of n minus 2 plus r to the power of n minus 3.
Okay.
Right. I always have one to match the pattern, right? So this matches the pattern.
So technically R is a different f.
So R is from nowhere. It comes from nowhere. It just jumps up here. Let's say R is some number.
Okay.
Right? So some number to the power of n matches this pattern.
Okay.
If you can make it match that pattern, that's how it goes.
Alright.
Right? So if you can accept that this works for that pattern,
so you can make it work for that thing.
I can make, if it works for this, it should have worked for that pattern.
Okay.
If you ignore the initial values.
Yeah.
Right? It fits that pattern.
Alright.
So if this fits that pattern, this should also fit the pattern.
What is that symbol?
Alpha.
Okay. What?
So I just multiply all of them by alpha.
So some number.
Yeah, some number. This should also fit it.
Yes.
Right? Because that doesn't affect the result.
If you divide everything by alpha, you get the same thing.
Yeah. Right? So multiply by alpha, it'll fit. So if you let a sub n equals to alpha times r to the power of n, everything follows, right?
Yeah.
You can write the exact same thing. The only difference is that, well, there's an alpha.
Yes.
Right? Okay. So now let's look at r here. Well, r is just some value. And then we may think about, well, then how many possible values are there for r?
Yes.
Right? So this can be simplified to r to the power of 2 equals r plus 1. I'm just dividing all of them by r to the power of n minus 2.
Okay. Can simplify this?
Yeah. So this can be simplified to that.
Okay.
Yeah.
Yeah.
All right. So that's a quadratic equation.
Oh, I saw something on what was it? ChatGPT told me if you let r equal to the sequence, and you can solve r is equal to quadratic formula, then input that back into the sequence.
Yeah.
But the answer did not look nice.
Okay. So from here, we get a quadratic equation, and we know how to solve a quadratic equation.
Why does it end with I though? Does it end with an I?
I?
Yeah. Well, this one ends with an I. The one that ChatGPT gave me ended with an I.
I'm not sure about that. Here it won't.
All right.
So let's solve this quadratic equation first. So let's solve it here. So we have r to the power of 2 minus r minus 1, right?
Yes.
So r equals negative b, which is 1,
Yes.
plus or minus square root of 1 plus 4, which is 5, over 2, right? So, well, we only get 2 possible values for r.
Wait, so this is the thing. So
That's the golden ratio.
Oh, okay.
1 plus square root of 5 over 2, that's the golden ratio, right?
Okay.
There are only 2 possible values for r, right?
Yep. And one of them's negative.
Okay. So, if that's the case, I can say that, well, if you get a value for r, this works. Then if you get a different value for r, it should also work. So if I put r sub 1 here, that means 1 value for r, then this should also work. Because this r works too. R sub 2. because we can get two different values for r,
Oh yeah.
right?
Okay.
Either, we can say that one is r sub 1, one is r sub 2. I don't want to write the whole thing here.
Yeah.
Because that's a big chunk of stuff, right? So this works, I can put a different number here, which is different than that one. They don't have to be the same number,
Yeah.
right? They can be the same number,
Okay.
but they don't have to be. So this works.
One of them is equal to plus and one's a minus.
Yes.
Okay.
Right? So the important thing is that we know that there are two possible values for r.
Yes.
Right? These two values will make it work.
Okay.
Right? So then this works. Then it's safe to say that if you add them up, the one will also work. Alpha,
Gamma. Too many letters.
So math is like a language, and you gotta get used to it. So alpha r sub 1 to the power of n plus beta r sub 2 to the power of n. This, well, you see that as something here. And then we have alpha r sub 1 to the power of n minus 1 plus beta r sub 2 to the power of n minus 1. Right? So then the next one here is, keep going, following that pattern. R sub 1, n minus 2 plus beta r sub 2, n minus 2. Right?
Yep. Okay.
So if you see this as some sort of a sequence,
Oh,
right?
okay.
If your a sub n equals to this,
Yeah.
it follows here,
Alright.
right? This works.
Yeah. It works.
Okay. So we can say
Wait, if you can make this turn into that? Well, if you say a of n is equal to that.
this. So if I write this in this format, because I know this thing works, right?
Yeah.
This thing works.
Yeah, it does.
So if I write this in this format, and if I can get f naught equals 0, f1 equals to 1, I can make it work.
Oh, if you satisfy the conditions.
Yeah. So when I just let it be like that, I can't really make f naught to be 0, f1 to be 1.
Yeah.
I can't. But if I write it this way, well, actually, it's possible.
Okay.
So how does it work? Because if I say f naught, right?
Yes.
So that'll be alpha times r sub 1 to the power of 0, which is 1. So you gotta make sure this equals to alpha plus beta. That's 0, right?
So therefore alpha is equal to negative beta.
Yes. And we know the other one is f1. Then when this is 1, you get alpha r sub 1 plus beta r sub 2, which equals to 1. All right?
Yeah.
So we know this value. We know this
Oh,
value.
okay, I see.
So now this time, I'm going to say clearly that this is r sub 1,
Okay.
this is r sub 2. Okay?
R, okay, whatever. Yes.
All right. So this is known, this is known. We don't know this, we don't know this.
Yes.
We have two equations, two unknowns. That's solvable,
I don't know.
right?
Yes.
It's solvable. So from here, I get alpha equals negative beta, so that we have alpha r sub 1 minus alpha r sub 2 equals 1. So alpha equals 1 over r sub 1 minus r sub 2.
Oh, okay, wait, hold on. if you say
Okay.
wait, how come they use alpha? Why can't they just use A?
It can be X, Y, and P, Q,
Okay,
or uppercase A and B.
okay,
Yeah, it's just two variables.
alright,
Okay.
okay.
Now we can actually calculate what this is.
Just do
Yeah,
some
so R sub 1, this, minus R sub 2, right?
Mm-hmm.
So if we go minus, plus, that's gone.
One
So
is
1 minus 1 is 0.
two,
2 of these divided by 2,
1.
that's square root of 5, right?
So alpha square root.
So this is 1 over square root of 5. That's what alpha is.
Oh, okay.
It's 1 over square root of 5. Right? So beta is just negative 1 over square root of 5. Right?
Yes.
So we have alpha and beta. Alright. So we know everything now. So f sub n equals alpha. It's 1 over square root of 5.
Okay.
Alright. So r sub 1 gives us 1 plus square root of 5 over 2 to the power of n. Then beta is
Minus.
negative 1 over square root of 5. And times 1 minus square root of 5 over 2 to the power of n.
Okay.
Right? And sometimes people rearrange this to some other format because these are both 1 over square root of 5.
You write 5
So
over
if
5.
you want, you can rewrite this
Root 5
as
over 5.
something like square root of 5 times 2 to the power of n. Then you write 1 plus square root of 5 to the power of n minus 1 minus square root of 5 to the power of n.
Oh, okay.
That, well, you can also see it in this format, right?
Do you get rid of the 1? Oh, no, you don't.
1,
Oh, you could get rid of the 1.
this one?
Yeah.
No.
Could you?
This is to the power of n. This is to the power of n.
But, like, isn't that still 1? 1 to the power of n is just 1.
No, this is bracket
Oh.
1 minus square root of 5 to the power of
It's
n.
better leave it in there.
Yeah, you can't cancel anything here.
Okay.
Okay? So, let's go over it. Yeah, you set that one, right?
Okay.
So that pattern fits this pattern,
Yeah.
right? If you add that this equals to r sub n, this pattern would follow, right? So, and then from here, we can simplify it to this. It becomes a quadratic equation. Then that quadratic equation can be solved, all right? So we get the two different values for r. Not many, right?
Yeah.
2. And you multiply it by some number, it'll still fit the pattern. And when you have 2 different values, you can write 2 of these here, and then you add them up, it becomes this, right?
Yes.
So then
Plug in
you
some
can
values.
get f sub n equals to this thing here, right?
Yeah.
If you can get it, the first term to be 0, the second term to be 1, then you can find the values of alpha and beta. Well, we did find it, right? We did find values for alpha and beta. And then we just plug every numbers in there. That's the formula.
Okay. Well,
Okay.
who thought of this?
Yeah, so that's a big formula, right? But the good thing is that the only thing changes here is n,
Yeah.
right?
I have a question.
Yeah.
Well, can you write the f of n equals the n minus 1, n minus 2 or something else? Or do you have to write it like this?
Let's say, well, for this pattern,
Yeah.
you
Does
can
it have
go,
to follow the
you can go with f sub n equals, let's say 3 f sub n minus 1 plus 2.
Yeah.
This method will still work.